Welcome to our lesson on area of circles and sectors. How can you find the area of a sector of a circle? Let's take a look at the area of a circle. Finding the area of a circle is harder than you may think. People struggled with this for thousands of years, from the Babylonian time period onward. Okay, Archimedes, Greek, and this would have been in BC, started with a circle. He inscribed a hexagon. Then he circumscribed a hexagon. He found the area of each hexagon, and the area of the circle is the average of the area of the two hexagons. Seems rather cumbersome, doesn't it? Method of exhaustion. So the more sides on the polygon, the more accurate the area will be. And they did this for a while, the ancients did. Then in the 1700s, not only did Newton, but so did Leibniz. They both came up with calculus, and thus, by using calculus, you can find the area of the circle. However, although this looks scary now, many of you will take calculus and discover it's actually pretty simple to understand. However, there is another method to find the area of a circle by using triangles. So we're going to start with a circle. We're going to divide it into a number of wedges. As the number of wedges is increased, the shape of each gets closer and closer to an isosceles triangle. Separate the top half from the bottom half. Okay. We're going to peel the wedges apart and we're going to line them up. And then we're going to slip them together. Allow for poor artistic rendering, and this shape looks like a what? That's right, it looks like a parallelogram. And the height is the same as the what of the circle? That's right, it's the same as the radius. And the length of the base is the same as the length of a what of a circle? The semicircle of the circle. So that would be pi r. So the area of the parallelogram is A equal to, that's right, pi r squared, which means that the area of the circle is equal to pi r squared. Let's take a look at example 1. We're going to find the area of the circle. We know that the radius is 7 inches. All we have to do is plug in the 7, and we get 49 pi inches squared. Or if you plug it into your calculator, you get a decimal of 153.94 inches squared. The area of a circle is 400 feet. Find the radius of the circle. So in this case, we know the area is 400. Now we just have to find r squared. Go ahead. That's right. It's going to be 400 over pi, or 127.32 is r squared. Must take the square root of that, so r is 11.28. Now then, let's take a look. What if we want to look at a sector? Remember that the circle sector is a region bounded by two radii and the incepted arc of a circle. In other words, the central angle. So we can write it as a proportion, okay? So we get the area over pi r squared, and that's equal to the proportion of your central angle over 360 degrees. And then all we have to do is solve for a. Notice the similarity between that and the arc length. The only difference is the arc length used the circumference of a circle. We're going to find the area of this sector. All right, so x is 50 and our r is 10. The rest of this is just the math of simplification, okay? And you can just plug it into the calculator. If you simplify it, this is the exact answer, 125 pi over 9. And if the problem asks you for an exact answer, you will use pi because this is just an approximate answer. Can anybody tell me why the difference? Okay, let's take a look at another example. You're going to find the area of sector ABC. Here we have our equation. Remember, x is 125 and 4 is our radius. Go ahead and solve. Alrighty, so as we simplify and work it down, notice that the exact answer would be 50 pi over 9, while your approximate answer is 17.45. The area of the sector of a circle is 32. What is the measure of the central angle if the radius of the circle is 6? So now we're going to set up our equation a little differently. Remember, 32 is going to go where the A is because that's the area. And we have the radius of 6. And that's going to go where the R is. So we get 32 is equal to x over 360 times pi 6 squared. This is now just a multi-step problem. Okay, so we're going to divide each side or multiply by 10 over pi. And so we get 320 over pi or 101.86 for our central angle. So the area of the sector of a circle is pi r squared, and the area of a sector is proportional to the measure of the central angle or the measure of the incepted arch. Leave answers in terms of pi when possible. Thank you for participating. It's going to be the end.